Hello friends, we're going to do something called linear programming. It just takes all the math skills you've already done and puts them together into kind of one big problem solving situation. The hardest part about these is just reading through the information, sorting it out, and kind of creating the numbers to start with. So there's steps here. It tells you to define your variables. So like tell what x equals, tell what y equals, and so on. This is probably the toughest thing, right? A system of linear inequalities that represent the constraints. Constraints are like limiting factors. So these are limits, things that you might run out of. So sometimes it's like, oh, I only have $100 to spend. So that's your constraint, your limit on money. Maybe you are making cookies, but you only have so much flour, and so on. So anything that limits what you can do is what you're going to be paying attention to. Then we're going to write an equation that needs to be maximized or minimized. So say you're doing a bake sale and you're trying to maximize your profit. You have to make sure that, you can only make as many cookies as you can make based on how much flour you have, but you're trying to maximize your profit within that. That is going to be called the objective function, because that's your objective. Your objective is to maximize your profit or whatever, minimize your cost, whatever it is you're trying to focus on. After we have all that, we're going to graph the feasible region. That's going to be inequalities and have it where all of the shading overlaps. So we're going to be looking for that overlap. We've done that before too. And then we're going to find the vertices. The vertices are going to be like the corners of that region. And they're going to be points. So we'll have like X and Y points for each vertex or corner. And then last, we are going to use those vertices, the corners of that feasible region, to determine the max and min value. And so at this point, we're going to be trying to find that max or min, whatever we're looking for. And you're going to be plugging into the objective function. Now, that is way too many steps for any of that to make sense. Usually the problems, and as we go on through the packet, are like a big fat word problem at the beginning, and you have to kind of create all of the things that you need. But in this first one, it's really laid out pretty basically. So you have a potter, somebody that's making like clay stuff, and they want to make bowls and plates, and they are going to sell them at a craft fair and try to maximize their profit. So this one does not have big sentences. It just tells you straight up. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. And you only have 40 pounds of clay. Alrighty, so the 40 pounds of clay is going to be my limit. I don't have any more than that. And then he wants to make at least 4 bowls. Okay, so the tricky thing is like separating everything out. I always watch for matching words like clay, clay, and clay. I need an equation around that. So in this problem, they did the equation for me, but down here is my clay equation. You're ultimately going to need to be able to write these yourself. And so they're telling you that X is the number of bowls and Y is the number of plates, because that's what we're trying to figure out, like how many of each should be made to maximize the profit. So this is saying you need 5, like it said right here, pounds of clay per bowl, and then you need 4 pounds of clay per plate. And you only have 40 pounds of clay, so you have to stay less than or equal to that. So that's where that equation came from. That's one of the constraints. Then here where it said he wants to make at least 4 bowls, that's this equation because X is greater than or equal to 4. And then this one is just like realistic. If Y is representing the number of plates, it has to be more than 0, greater than or equal to 0, because you can't have negative plates. So what we've done so far is we defined our variables, meaning we said that they're going to be the number of bowls and the number of plates. We kind of had help. They wrote the system of inequalities for us, but that's what this is down here. This one didn't give us the information to write the objective function, but we're trying to maximize our profit. So that's down here. The profit equation is this. And what this tells me is that my profit's going to be $35 per every bowl that I make and $30 per plate, because Y is plates. So I'm just kind of, and so on the other problems, that would be in a sentence. It would talk about making $35 per bowl and $30 per plate to help you build this profit or objective function that you're trying to maximize. Okay, so that's the equation that needs to be maximized. In this case, we're trying to maximize our profit. Now you're supposed to graph the feasible region. So that's going to be the 3 inequalities. Don't make this harder than it is. We've already done this. This has only X, so this is going to be vertical. And it's going to be greater than or equal to 4. So greater than or equal to a solid. So there's that. And then it will be shaded to the right. I'm not going to do all my shading quite yet. Well, I guess I can. So if I shaded this all in to the right, anything to the right of that has x's greater than 4. So I can make 5. And actually at some point I won't be able to keep going. I'll run out of clay. But for right now, I'm going to just shade off to the right of this. So over here, I'm making more than 4. The bottom equation is going to be this y greater than or equal to 0. Well, that's just going to be the x-axis. I have to stay above that. So I'm going to have to stay above that, which puts me in that same region, but over here. So far, this area over to the right and above 0 is what I'm looking at for the 2 equations. And for my last equation, this guy, I'm going to be doing what I always do with standard form and make a zeros table. So I'm kind of going to the extremes. I'm saying, what if x is 0? I don't make any bowls. Then 4y would have to be 40, so y would be 10. Then I go to the other extreme. What if I don't make any of y's, 0 plates? Well, then 5x would be 40, and that's going to be 5 times 8. And the reason I like to do that is now these are easier for me to graph. I just go from to 0, 10, and then to 8, 0, and I have to stay less than or equal to that. So I'll be underneath or below that line. So if I connect these and then allow Notability to make it straighter, thank you very much, and I'm shading below it, then that would mean this is the region where I have enough clay. So the part that I'm ultimately interested in, the feasible region that it talked about, is going to be this part that is where all 3 overlap. So over here was more than 4 bowls, but I don't have enough clay to make that much. And then over here, I'm staying underneath the amount of clay I have, but I have to make at least 4 bowls. So this region right here where all of the constraints overlap, I'm making at least 4 bowls, but I'm not using more than 40 pounds of clay. This is my feasible region. You want to make it really clear where your feasible region is. The vertices are going to be the corners. So there's one here, and one here. Sorry. So the ones that are on the axis, I don't have to do any math. This one is at 4, 0. The next one is at 8, 0. And then the last one, I have to do a little bit of math to kind of come up with that one. Sorry, I opened my computer and I had a totally different equation. Okay, and then here, if I am not sure where they cross, I could go back and remember that, hey, I know how to solve these. They told me that x is 4, so I'd have 5 times 4 plus 4y, and I'm trying to figure out when that would equal the 40. This will be 20, which I can take away. And I'd end up with 4y equals 20. So 4 and then 5 is going to be where that crosses, which actually looks like 4 or 5. So these are my coordinates for the 3 vertices. Then I'm going to be, because it says graph the feasible region, and label the vertices, which we did. Now I'm going to plug those vertices into my objective function. So here I'm going to say, okay, what is my profit? I'm going to use this first one. If I make 4 bowls, but I make 0 plates. And so I'm just kind of plugging that in. That turns out to be $140. In this second one, I'm going to make 8 bowls, but 0 plates. And so here I end up with $280. Here I'm going to make a combination. I'm going to go ahead and make 4 bowls, and then I'm going to make 5 plates. Kind of flip-flop these, sorry, I hope that didn't confuse you. And when I put that through my computer or calculator, I get $290. And then I just look, since this is the biggest number, that combination maximizes my profit. And so when you're done, you just make a statement. This one says a maximum profit of $290 occurs with, and then it's going to be 4, keep in mind what X was representing, 4 bowls and 5 plates. So in the end, you're just stating like what is the best thing to do. So to maximize your profit, that's the best thing to do. Hopefully that helps.